Ah, yes. Once again, I forget to close the VTube Studio overlay. One day I'll remember. Okay, hello. Welcome back, everyone. Today is May 23rd. It's Turtle Day. So that means we're going to be doing a little bit of science, a little bit of learning, a little bit of knowledge. Let me just grab up a couple of things here. Grab up my notes. And we will get underway. So, forewarning: there may be science will happen. There will be some words that may be complicated and Latiny. There may be a lot of things that seem a little bit overwhelming. I'm going to try and break it down and make it pretty simple, but forewarning, I really like science, so much so that I did a science degree. I really like turtles. I like talking about turtles. Therefore, I will probably talk about turtles to an unhealthy extent with a lot of complicated things mentioned in between. Now, with that out of the way, let's get started. So, welcome, an introduction to turtles. Turtles are found in this chunk roughly of the world. So basically, turtles are found throughout both the... Oh, thank you, Sin. Thank you for Happy Turtle Day. It is indeed a Happy Turtle Day. So turtles are found in both the northern and southern hemispheres, although with a slight bias towards the southern hemisphere. They are found on every continent in the world, except for Antarctica. But obviously, we have some slight limitations up north towards Russia, Finland, places like that, because being reptiles, we do not like cold climates. So, moving on. I'm just going to talk about this real quick. This is kind of something that I knocked up for other presentations I'm going to be doing in the future. Just to talk about evolution and fitness. So, most people have a pretty rudimentary understanding of evolution, and it's usually kind of Pokemon. It's, Bulbasaur becomes Venusaur, Bulbasaur, Ivysaur, Venusaur, that's it. I know my Pokemon. I didn't just fail at my knowledge. So, what does survival of the fittest mean? Survival of the fittest does not mean the strongest, the fastest, the biggest, the smartest. Survival of the fittest just means the most suited to the environment they live in. So, if you're good enough, then you can make a pretty good job of surviving, which is largely speaking what turtles have done, even though they have some pretty good adaptations to their environment that are very flexible and let them live in a variety of different areas. More importantly, what we talk about in science nowadays tends to be reproductive fitness, which is how good are you at getting some, right? How good are you at finding some attractive he turtles or she turtles and getting busy making more turtles. So reproductive fitness is basically any trait that helps you get busy. It contributes to reproductive fitness. Any trait that damages you from getting busy, like being a VTuber, these things all decrease reproductive fitness. So generally speaking, we refer to organisms as being reproductively fit or reproductively unfit. Furthermore, evolution is a pretty gradual thing. Organisms that have been around for a long time, like turtles, aren't necessarily more advanced or more primitive. Turtles, Ludicool, welcome in. Happy Turtle Day. I'm glad you're learning. So, organisms that have been around for a long time, like turtles, may be what's called more derived, which means that they are different compared to their ancestral forms. A great example is turtle shells. So early ancestral turtles didn't really have much of a shell. They kind of had, a proto shell, bits and pieces of armor, but they weren't fully formed. Whereas modern turtles, like me, had this nice big, wrong button. Nice big carapace on our backs. But that doesn't mean that I'm more advanced than my ancestors. It just means that I am different. So organisms can be reproductively fit while only being good enough. And did I mention this one in here? So evolution is not teleological. You don't start at something simple and become advanced. It's just whatever works stays. And as I mentioned earlier, unless something's detrimental to fitness, it may be retained in a population indefinitely. And I'll talk about that in a little bit with the sulcata tortoise, because it's both sad and amusing what the greatest threat to them actually is. And last of all, a beneficial trait in one environment may be detrimental in another, which is, again, an interesting one for turtles, because we have this big heavy shell, and that can be really useful in some ways and really kind of not useful in others. Liz, welcome in. Welcome in. Happy Turtle Day. So now that we've gotten the boring bit out of the way, let's move on to the other stuff. So, what are turtles? So, turtles are vertebrate amniotes, which means that they are, well, vertebrate tetrapod amniotes, which basically means that they have a spine, a bony vertebral column. We're tetrapods, which means we have 4 limbs, which includes all other reptiles, mammals, and birds. Yes, birds are tetrapods. They have wings and feet, which counts as 4 limbs. And then we're amniotes, which mean that we lay eggs. We have a membrane-bound offspring, basically. Simplified down a bit. So turtles are reptiles, and we're classified in the order of testudines, alternatively chelonia. This is one of those funky things about science, particularly taxonomy and all those other things. Back in like the 18th century, people went out in the world and were like, hey, we're going to name shit. We're going to give things Latin names or maybe Greek names. We can't decide. Sometimes we'll give things Latin and Greek names. So some guys were like, hey, we're going to call these testudines, which is Latin for turtle, basically. Whereas other people were like, no, we're going to call them chelonians, which is Greek for turtle. So testudine, chelonia basically means the same thing. Testudine is a little bit more common nowadays, but they're basically identical. So turtles first appeared about 230 million years ago in the Triassic period. We are one of the oldest of the modern reptile groups. We predate a lot of the dinosaurs, not all of them, but a lot of them. Particularly things like, again, Tyrannosaurus, stuff like that. Turtles beat them to the goal by a couple of million years. The evolution of turtles is kind of a bit weird. We don't really know where they started, because there are a lot of things out there where we're in the fossil record where we're kind of like, it's kind of like a turtle, but it doesn't really have the full shell and other traits that are associated with turtles. Originally thought to be descended from the anapsids, turtles are now kind of considered to be our own reptile branch. I'll get onto that in a minute, what an anapsid actually is. Turtles are well known for our shells. What actually is a turtle shell? Well, believe it or not, a turtle shell is actually a fusion of the ribs. The turtle's ribs fuse over its evolutionary history into a single kind of solid mass, which protects all of the visceral organs inside the torso, and as well as most of our muscles and things like that. So the interior of the shell is bone, and then it's covered by a layer of scales that are made from keratin, just like what your hair would be made from, or your fingernails. And it's a question I often get asked. Snakes shed their skin, geckos shed their skin. Do turtles shed? And the answer is actually yes. Yes, they do. So if you look up on my shell, you can see those little plates around the edges. Those are essentially scales, large keratinous scales. When I or another turtle would be in shed, those will actually break off. They'll basically, an external, the older layer will break off. It essentially looks like just a large chip of plastic or like ceramic, and there'll be some nice new shiny fresh shell underneath, and they just break off in chunks. So unlike snakes, we don't shed in one piece. It just kind of all the bits break off till we've got a nice new fresh shell. And depending on the species, you can see this more prominently than on others. A great example, again, is sulcata tortoises. They get a really interesting striation on their shell where you can see effectively growth rings of where the shell has grown and changed. And overall, turtles are divided into 2 major groups, which are the Pleurodira. the side neck turtles, which are the slightly older group, and then the Cryptodira, which are the hidden neck turtles. So the Cryptodira are the ones that you might consider to be the most classic turtle, the turtle with the head that goes into the shell, like you would have seen in a cartoon or something. The Pleurodira are actually the turtles that I'm more familiar with because they're what's more common where I am in the world, in Australia. So this is just a quick diagram of the shell of a turtle. The top part of the shell is known as the carapace, and the underbelly is known as the plastron. These plates on the underbelly, on the plastron, these are called scutes. It comes from the Latin word scutum, meaning shield, but I always remember it because it's what you scoot along on. You go... The plastron and the carapace will vary in size and shape depending on the species. Some species have very large... this one, I believe, is for a common snapping turtle. Has quite a large plastron. But things like, for instance, the mata and softshell turtles have severely reduced plastron, and in case of the softshell turtles, severely reduced carapace as well. So just keep on moving on. So, anapsids. I said that word earlier. What does it mean? Well, if you look at a skull, you'll notice skulls have got holes in them. You got your eyeball holes, but you got other holes in the skull as well. So, historically, tetrapod vertebrates have been classified by the number of holes in their skulls, fenestrae. The three main ones were the synapsids, the diapsids, and the anapsids. There are some other ones as well, but they're annoying because they're mainly fossils, and I'm not going to talk about them. So, synapsids, most mammals, they have one fenestrae. They have one hole in the skull. The fenestrae are used for anchoring muscles for working the jaw. Humans have fenestrae. You can't really, they're hard to see, but kind of like if you feel up on like the side of your head when you move your jaw, you can kind of feel some muscle moving, and that will be around where your fenestrae is in your skull. Reptiles and birds, they have their diapsids. They have two fenestrae, so they have two holes for anchoring their jaws. And then turtles. Turtles are anapsids. We have no fenestrae. We just kind of anchor our muscles to various parts of our skull rather than having a hole for them to go through. Now, for a long time, this meant that scientists thought that turtles were relatively primitive because the anapsid in the fossil record were some of the first organisms to appear, some of the first kind of tetrapod vertebrates. And so it was for a long time thought that turtles had actually split off into their own group from the reptiles pretty early on, and that they had a very primitive body plan. However, some more recent research has actually suggested that they're not descended from the anapsids that closely, and that actually we kind of went backwards. We went down the same route as our reptile friends in the diapsids, and then decided, nah, fuck this, fenestrae are overrated, and went back to having smooth skulls. So I guess that explains my smooth brain. So that happens, and as I mentioned earlier, again, reproductive fitness is based on, you know, what helps you get busy, not anything else. So having two fenestrae helps the reptiles, having no fenestrae either helps or doesn't impact turtles in living our lives. So going backwards and losing those may have been due to a selection pressure that gave us a particular advantage, but at the very least, it doesn't prevent turtles from thriving in the wild. So let's talk about the Pleurodira, the side neck turtles. These guys are the oldest branch, and I'm going to have some examples, so don't worry. I know there's a lot of words, but there will be pictures too. There will be turtles, and they're very cute. So, oldest branch of testudines. These guys protect their head by wrapping it to the side under the margins of the shell, because they can't actually, the way their muscles and vertebrae are shaped, they cannot actually pull their neck back into their shell like the cryptodines can. So, the Cryptodira. Instead, their cervical vertebrae, so all turtles have 8 cervical vertebrae in their neck. The Pleurodira, theirs are kind of a cylindrical spool shape, and this allows them to have quite a fair bit of side-to-side movement. It's also one of the reasons why the majority of Pleurodira are either opportunistic omnivores or active carnivores. They're very good hunters because they have a very wide motion of neck. And trust me, we're going to see some necks. We're going to see some necky boys. These guys are found mainly in the southern hemisphere, so Africa, Australia, South America. And they're the smaller of the two groups, but historically they were, again, a bit more cosmopolitan, so they were spread out across every continent previously. They're mainly confined to terrestrial and freshwater ecosystems. You do have some species that kind of happily live in kind of a semi-terrestrial or semi-aquatic lifestyle, but things like, again, the mata mata, which we'll talk about in a minute, they spend most of their time underwater. Historically, there were marine species of the Pleurodira. Unfortunately, they're all extinct now. The only extant marine turtles are all Cryptodira. But where was I going with that thought? Yes. So anyway, my train of thought has escaped me, as it is wont to do. Anyway, moving on. So the mata mata, who I just mentioned, Chelys fimbrata. Look at that face. Look at that absolutely zero thoughts, head empty face. I love him. He is adorable and wonderful, and I love him. So these guys are found in South America. They have had a very tumultuous taxonomic time. I think they got renamed something in the order of 14 times in 100 years. So their current name, Chelys fimbriata, was given to them in 1992. They're found in South America, particularly in the Amazon and I think Orinoco basins. There is some recent evidence to suggest that they're actually two species, because the Chelys fimbriata, which is found in the Amazon, has a very distinct set of morphological differences between the Amazon population and the other one, the Orinoco population. So there's been some suggestion that we may actually need to split them in two and say, hey, they're actually two separate species. But these guys are pretty interesting. They're quite large as far as turtles go, or at least freshwater turtles. They're equivalent in size to their North American cousins, the snapping turtles. And they're also predators. These guys are obligate carnivores, but they're a little bit different to their snapping turtle cousins because these guys are ambush predators. Basically, what they do is they sit in a nice muddy bit of water, and you'll notice the schnoz. They got a very long nose. They use that to kind of stick their head up and breathe without really needing to move. And you'll notice they've got all these frills and fringes around the side of their head. Now, these are very sensitive. It allows them to detect motion, and it also camouflages them. So when they're sitting in the water, they just look like a bit of stick and leaf. And they wait for a nice little fish to swim on by, and then they do what they're doing in the top right here. They open their mouth, and these guys have a fucking huge mouth proportional to the rest of their head. And what that does is it generates a vacuum. So when they open their mouth like this, it creates a whole bunch of suction. He big suck boy. And that means that any fish that's right in front of him just gets straight into the throat. And then they shut their mouth very quickly, which expels all the water, and they basically swallow the fish or whatever small insect that they've grabbed whole. These guys eat mainly fish, but they will also take small mammals, small birds, small reptiles in the water if they can get them. But they're a very interesting species. Again, just so absolutely adorably zero-head thoughts. So, moving on. Eastern long-necked turtle, Chelonia longicollis. If you live in Australia on the east coast, these guys are probably pretty familiar. You can find them in most ponds and creeks around the east coast of Australia. They're relatively common on the pet trade as well. These guys are pretty much an archetypical side neck turtle. So you can see in the bottom right here, we've got this guy, he's tucking his head. This is how the side neck turtles work. They basically just fold their head under the margin of the shell, and it gives them a reasonable amount of protection. these guys are actually pretty interesting in that they overlap with quite a few other turtles in terms of area of habitat. And actually, in the Styx River up in Brisbane, they will actually it's Queensland. It's up in Queensland somewhere. These guys will freely hybridize with other turtle species there, which means that they basically just whatever's on offer is good to them. They'll get knocking with anyone. But yeah, very common turtle. They're also colloquially known as stinkers because they have a set of musk glands in their anus that if they feel a bit concerned, they will give you a nice big squirt with some pretty foul smelling compounds. But these guys are unlike the Mata Mata. These guys aren't entirely carnivorous. They're obligate. They're not obligate carnivores. They're opportunistic omnivores. So they'll take more or less anything they can fit in their mouth. It's mostly small crustaceans, small fish, things like that. But I have seen one of these take a duckling. They will take anything they can fit in their mouth. But yeah, pretty common and a pretty good example of what our typical side-necked turtle looks like. So next up, we got this boy, the broad-shelled river turtle, Chelidina, I'll get onto that in a second, expansa. So I mentioned we were going to have some long boys, right? Long boys. These guys have the record for the longest neck of any turtle, right? An adult broad-shelled river turtle has a shell length of about 50 centimeters, half a meter. Their neck is as long as, and in some cases longer than, their shell. These guys have a total length of about a meter, 50% of which is neck. So yeah, my reaction exactly, Liz. Look at that long boy. These guys are amazing and I love them. They're found in the Murray River Basin. Unfortunately, their population is not doing so great. So these guys are really cool. They're very similar to the previously mentioned long-necked turtle, the eastern snake-necked turtle, and they actually cohabit with them pretty commonly. These guys, however, have some interesting quirks to them, one of which is the fact that they're actually one of the longest gestating turtles ever, as far as we're aware. These guys went from laying the eggs stay in the ground for approximately 350 to 360 days, almost a year. This causes some issues, namely that because they're in the ground so long, the eggs are very vulnerable to predators, things like goannas, but also foxes, feral cats, things like that. And it's estimated in the Murray-Darling Basin that due to foxes, they're at about 93% nest predation, which basically means that 93% of nests don't make it. They get attacked by foxes. And this is kind of a problem because, again, these guys are in the ground so long, it just gives so much more chance for them to get taken out. The other issue is that they need rain. So these guys hatch, and they'll hatch in the nest and stay in the ground. But the hatchlings won't actually leave the nest until it gets inundated with water, with rain, because the sand that they're in is so tightly packed that they need that water to loosen it. So in a bad season when it doesn't rain, the hatchlings can't get out of the nest. And unfortunately, climate change and mismanagement of water resources in the Murray-Darling Basin means that these guys are struggling a little bit. The other problem is that these guys live for a fair while. We don't actually know how long, but some estimates say up to 70 to 80 years, potentially. They're one of the longest lived turtles out there, as far as we can understand. And that means that often it's very hard to gauge how well the population is doing because people go, oh yeah, there's loads of turtles, there's loads of long necks. The problem is that a lot of these might be very, very old with no real ability to recruit new, younger individuals into the population. So hopefully we can do better and manage these guys better, because I don't want to live in a world where there's no long necky boys. I want long necky boys for days in my life. Thank you very much. All right. And also, you might have noticed how I said Chelonia, Chilidira, and kind of mumbled that off. Yeah, that's because these guys are a bit weird in that they're in their own little like subgroup, because cladistics is hard. Okay, moving on. The Mary River Turtle, Elusa macros. I fucking hate saying Latin. Anyway, so the Mary River Turtle, aka the Pet Shop Turtle, aka the Penny Turtle, aka the Soft Shell Turtle, aka the Punk Turtle. Yeah, I think I got about all the aliases there. So, why do these guys have so many names, and what's so interesting about these? So, the Mary River Turtle has been known about in Australia since about the 1960s, but it wasn't officially classified until 1994. Why? Because scientists didn't actually know that it was a different species of turtle. For a long time, these guys were very commonly collected from the Mary River and sold in pet shops, hence the name pet shop turtle or penny turtle. But for a long, long time, again, like these were just like pet shop owners would go out, collect them, and sell them. And most, as far as most people were aware, they were just another type of, again, eastern long-necked turtle. It wasn't until 1994 when I believe he was a scientist and turtle enthusiast, was in a pet shop, and he noticed this thing was like, he noticed one of these in a shop, and so was like, this is different. This doesn't look like the turtle I'm used to. And so he inquired about it. He asked the shop owner, he said, where did you get this? And the shop owner just, I don't know, just out like in the river. And so it took him about 2 years of searching until he finally figured out that these turtles were coming from the Mary River and that they were a different species. The naming kind of was in flux for a bit, and that's why they kind of settled on Elusa macrurus, basically, the elusive turtle. And that's also why the name was so variable, because they weren't entirely sure where they were coming from. That's why they finally got the name the Mary River Turtle. Originally, they were called the Soft Shell Turtle because if you can see on the left-hand photo, this guy, the margin of his shell has these serrations. That was their original kind of name that they were giving it. However, there are a number of turtles out there with the name Soft-shelled Turtle, so they eventually went with a different one. And its common nickname, the Punk Turtle, comes from this picture on the right. These guys have a really common phenomenon, which is they get algae growing on them, usually on the shell and on the head, which often gives them kind of this like mohawk of algae. But aside from that, yeah, they're a pretty normal turtle. Again, like a lot of Australian turtles, they're not doing great in the wild. Part of this comes from the fact that they were so common as a pet shop turtle for decades. So unfortunately, the population has been impacted by that, by over-collecting and other things, but hopefully, again, we'll see a bit of a recovery in the future. And they're pretty common on the pet trade still, just because a lot of people have them and now breed them captively instead of collecting them from the wild. So hopefully we will see a kind of more abundant population of these guys and their funky haircuts in the future. So let's go on to the Cryptodira. Are we all good? Do we need a drink break? Do we need anything? Any questions before we get onto the hidden boys? Okay, I'll take that as a no. We will continue on. So, Cryptodira, hidden-necked turtles. These guys have freshwater turtles, snapping turtles, tortoises, soft-shell turtles, and sea turtles. Now, some of you are probably going to ask, what's the difference between a turtle, a tortoise, and a terrapin? The answer is basically nothing. Funnily enough, the English language, much like any language, picks up words in kind of a random way. I've heard many different explanations about what means what. The common distinction that most people will say is that turtles live in water, tortoises live on land. That's good enough for a broad categorization. But generally speaking, it means nothing. They're not like all the tortoises are in slightly different families. They're not all in one group like toads are. There are turtles that happily live on land, like the box turtles, who we'll talk about in a minute. They're pretty terrestrial without being tortoises. So all the names, again, just are very different labels for varieties of the same thing. But broadly speaking, the most accurate colloquialism is, again, turtles live in water, tortoise live on land. But really, again, the terms mean nothing. So if you see something out in the world and you call it a turtle, that isn't 100% accurate. These guys are incredibly diverse, much more so than the side neck turtles. The side neck turtles mostly live in water. The Cryptodira live in all sorts of environments, from deserts to rainforests to savannas to rivers and even the ocean. Exactly why this is the case, we don't entirely know, but they're again a very interesting group in terms of the range of habitats they live in, but they do have some very common unifying factors, and the main one is they pull their neck backwards and up into the shell to retract their head. They basically have some weird joints in their neck, and they pull their head back in like an S shape, which also causes their kind of like neck skin to like fold around their head. It's kind of weird and a little bit gross. So that gives them quite a bit of protection. Also, interestingly enough, and we'll talk about this in a minute, but when they retract their head into the shell, there are actually quite a few species that aren't able to breathe when they do this because of how turtles breathe, which we'll touch on in a minute. When they pull their head back into the shell, they can't actually expand their lungs. So, in theory, this gives them a limit for how long they can stay inside their shell protecting themselves. However, most turtles are actually pretty good at holding their breath for quite a considerable amount of time. So usually they can just stay tucked in and hidden long enough to protect themselves for a potential predator to lose interest and go away. So, the snapping turtles. These guys are kind of a weird one in that they're I guess you could say a family of species. So on the top we have the alligator snapping turtle. They were a single species. Yeah, very kissable. If you look at the shell on the top one, you may notice some similarity to my shell. Yes, the design of Ando's shell was based off of an alligator snapping turtle. Ando is not actually based on any one particular turtle species, but I thought the texture on the shell looked good, so that's what we got. If you look at my reference sheet on Twitter, and you look at the back view, yeah, that's the shell that I've got. Alligator snapping turtles are kind of interesting because they're the larger of the two groups in terms of physical size. They were originally thought to contain only one species. However, in 2014, they split them into three, and they're considering that they might actually even be a fourth. So you'll also notice if you look in the mouth, you can see this little pink guy right here. This is a modified piece of the tongue that they use. They use it as a lure. So what they'll do is they'll sit in the water like this, right? Very, very camouflaged. They just look like kind of like a bit of a log. And they have this little pink guy that they wiggle around like a worm. And a little fish will come by and be like, that looks very tasty, worm. I will have this worm. Oh no, inevitable betrayal when they get sliced in half by this giant set of jaws. Interestingly enough, as I mentioned before, turtles are anapsids, which means that they don't have temporal fenestrae in the skull. They don't really have anywhere to anchor their skull muscles to for biting. So snapping turtles actually don't have that high of a bite force. However, bite force is kind of overrated when your head is essentially a giant pair of bolt cutters and you snap the jaw shut very, very fast. They also have their neck can extend out quite a fair distance. The common snapping turtles down the bottom, their necks tend to extend out further, but the alligator snapping turtle can still get you from a decent distance away. And these guys kind of share a range. They're found in the northern, like North America, so the United States, generally and speaking, in the southeast. It's very interesting because you can actually, if you look at the westernmost border of their range, it actually matches up with one of the mountain ranges in America. I think it's the Rockies. It's basically the only reason why you don't find these guys on the west half of America is because they can't get over that mountain range. So in theory, if you really wanted to try and fuck up some American ecosystems, you could airdrop some of these guys on the western side of the continent and see what happens. But yeah, very, very interesting guys. They're somewhat primitive in some regards. They tend to have a very... I wouldn't say primitive, but they're not strong swimmers. They live in water, but they don't really swim. They kind of like walk around on the bottom and just bury themselves in mud and wait for something to swim past and go, But yeah, very, very cool. Handle with caution. If you see one of these guys in the wild, don't fuck with it. Don't try and pick it up. Both the alligator and the common snapping turtle will happily and easily take a finger. They'll probably even take multiple fingers. So yeah, treat them with respect. Perhaps reconsider the smooching sin because, they may not take kindly because they're ungrateful. Now we got this guy, the pig-nosed turtle, Caretochelys insculpata. I love these guys. They're adorable. Look at that happy boy on the left and that grumpy boy on the right. These guys are found in Northern Australia. They're also known as the fly river turtle. They're really cool for a number of reasons. First off, they're a freshwater turtle, but they're almost entirely aquatic. They only come onto land to breed. Actually, not even to breed, to lay eggs. And if you look at them, they look really similar to a sea turtle. They more or less don't have feet. They have flippers. That's why these guys are a good example of, I guess you could say, convergent evolution, in that they've reached a similar body plan to the sea turtles, even though that they don't live in the same environment and they're not actually that closely related to them. These guys are actually more closely related to soft shell turtles, which you can kind of tell from their kind of they don't have the dermal plates on their shells. Their shells are actually kind of fleshy, although they do still have the fused ribs and kind of the armoring underneath, so it does offer them some protection. These guys also have some really interesting traits in terms of their reproduction. So these guys lay their eggs in the sandy riverbanks up in the Northern Territory, and they do what's called a diapause, in that the eggs become dormant over the dry season. So the embryo inside will fully develop. It will become a full-grown turtle, but it won't hatch. And it does that for two reasons. One is that synchronized hatching is a very, very strong evolutionary advantage for turtles. It's a very strong benefit to their reproductive fitness. Because if your nests or your eggs all hatch at different times, you get like one or two babies coming out of the nest, and then they get eaten by birds and goannas and other things like that. Turtles, generally speaking, are at their greatest risk when they are small. Turtles very much have kind of an R-style life history, in that their greatest mortality rate is when they are small, and when they get past, I guess you say, adolescence, they're generally at less threat of predation. So by having all the turtles hatch at once, it's kind of like a "fuck you, you can't eat us all" scenario. They just become a horde of turtles heading towards the water, so that, even if the crabs and the goannas and the birds try and eat some of them, they can't eat all of them. But kind of how do you manage that in a place like Kakadu, where you have a long dry season and then a rainy season? Well, these guys, as I mentioned, go into diapause. They develop in their shell, they stay in their eggshell, and then they do not hatch until the nest becomes submerged in water. Not just there's a little bit of water, the nest has to fill with water, which is actually how they hatch these guys in captivity is they will take the eggs out of the nest, they'll put them in an incubator, and when it's time to hatch them, they literally just dump them in a tub of water, which means that the little hatchlings have to break out of the shell underwater and then just go straight to swimming, which is pretty cool. Now you might think, oh, that's not great. These guys are like underwater and they're babies. Won't they drown? The answer is not really. They have pretty good at holding their breath, and they have some other tricks up their sleeve. That means that staying underwater, even as babies, isn't really too much of a problem. So yeah, pig-nosed turtles. I love these dudes. They're adorable. So next up, the box turtles. These guys are actually a full genus with multiple species, to the point that they actually have fucking subspecies. They're a real nuisance from that sort of things, because so you've got like genus Terrapene, which is like all of them, but then you'll have like Terrapene whatever from like particular states in the US. I'm not going to go into it because, again, North American turtles are not my specialty, but I figured these guys have some really interesting stuff I wanted to talk about anyway. So look at these guys. Look at how fucking fantastic they are. Look at how pretty they are, and look at how absolutely grumpy they are. I've never seen a box turtle that looks happy. These guys always look like they are fucking pissed off about something, and I love it. Next off, if you look at the shell on the right, you might be thinking, hang on a minute, where the fuck is his head and legs gone? Good question. So, box turtles, there's actually two types of box turtle. There's the American box turtles and the Asian box turtles. They're not related. They're both cryptid retracting head ones. What's the word? Cryptidanes. But they're kind of different, and they're named box turtles for different reasons. The American box turtles have this really cool adaptation where they actually have a hinge built into their plastron, which they can use to essentially close their shell like a box. So what these guys will do when they're threatened is they'll pull their head in, they'll pull their legs in, and then they'll pull up their little drawbridge, and they are a perfectly sealed armored shell. And they will stay like that until whatever is annoying them has gone away, and they'll peek out. So if something has gone away, they'll kind of drop the drawbridge a little bit, look out. If they don't like things, they'll tuck their head back in, pull it up, and just wait until the predator has gone away, and then they'll drop their drawbridge down, pop their heads out, pop their legs out, and go on their way. The other thing that's really interesting about these guys is that they have homing behavior, in the sense that they live terrestrially. They'll wander around the forests and the fields, you know, doing their thing, munching on various insects and berries and other stuff that they find, but they return to their home locations to breed. And we're not entirely sure how they know, but they basically, like a homing pigeon, can just figure out, yep, I need to go this away to get to where I need to be. This unfortunately causes them some problems when it comes to things like roads, because these guys are stubborn little bastards, and they will quite happily just be like, cool, I need to go this away, and proceed to march across an 8-lane highway. This also causes a lot of problems where people try and help these guys, because what they will do is they will pick the turtle up and go, oh, Mr. Turtle, you shouldn't be in the middle of the road. I'm just going to put you off here to the side. And the turtle will proceed to turn around and be like, no, fuck this. I have to go that away, and keep on walking. So generally speaking, the advice with these guys is if you find one in the wild and it's somewhere where it shouldn't be, i.e. it's walking across a road or something like that, don't take it elsewhere. Don't pick it up and take it home or anything like that. Pick it up and carry it in the direction it was heading, because it will want to head that direction anyway. No matter where you move it, it will try and get back to where it was going. So again, if you just pick it up and put it off to one side of the road, it will turn around and just keep walking back. So take it in the direction it was going, put it down, and it will walk off happily to try and find home. Very cool little turtles. Okay, next up, the African spurred tortoise. I had to put at least one tortoise in here. Centrochelys sulcata. These guys are also known as sulcata tortoises. They are the third largest tortoise in the world. They're the largest mainland tortoise. They're the largest tortoise in Africa. Only the Aladabra and Galapagos tortoises are larger, and they're found on island chains. These guys are pretty interesting for a lot of reasons. One, as you can see on the right, they start off as being absolutely tiny. The babies are like 40 grams, yeah? An adult one of these guys can weigh up to 100 kilos, and they grow incredibly quickly in their first year. So an adult sulcata tortoise can weigh up to about 80 to 100 kilos, and can be up to a meter in length. They're pretty hefty, and they'll live up to about 80 years. They're quite popular on the pet trade, but this again can cause some problems sometimes because they do get quite large, and much like the box turtle, these guys are stubborn bastards. So you see that photo in the middle? Yeah, I found that on Reddit. It's a guy who had a sulcata tortoise. That's a male sulcata tortoise, and he had him in his own room. But my boy was getting a bit randy. He wanted to get busy with the ladies, and so he decided that he didn't want to be in his own room anymore. And so he dug through brick and then through drywall, and then proceeded to demolish that little hole he's made right there, just so he can go and get some. So, well done, my brother. You live strong and get all the lady turtles you want. But yeah, these guys are prodigious burrowers and really stubborn. So there is very little that you can put in the way of a determined sulcata tortoise that will stop it. You can do it, but again, it takes some effort. And yeah, they're prodigious burrowers in their home range in Africa. They live in kind of sub-Saharan plains around kind of the north and central parts of Africa. They usually dig quite large burrow complexes, and they use these to estivate during the day. So during the hotter part of the day, they'll move into the lower part of their burrow where they'll sleep, and then come out in the morning and the afternoon when it's cooler to kind of do their foraging. These guys are mostly herbivorous. They eat things like prickly pear cacti, succulent plants, any kind of berries and stuff they'll find, fruits. But they will also opportunistically take meat as well. In captivity, you shouldn't actually feed these guys meat too much. So as I mentioned earlier with the shell growth, you can kind of see the growth rings on these sulcatas. And you can see this one's got some quite prominent ridges on the shell. That's pretty normal for a sulcata, but it can also become what's known as pyramiding, which is where if you feed them too much protein or they don't get enough sunlight, they will develop MBD, metabolic bone disease, and pyramiding, which is a side effect of that, which is where the shell doesn't develop properly, and so it gets too pointy, and that can cause them problems later in life. Now, speaking of problems later in life and shells, as little babies, the little babies we can see there, sulcata tortoises are vulnerable to a variety of predators, things like goannas, birds, and again some of the large mammalian or larger mammalian predators, things like wild dogs. However, as adults, once they reach their teen years, the sulcata tortoise is effectively immune to most any predator in the wild. They are functionally invulnerable, and also relatively docile, but when threatened, they will happily have a go at you. They bite. They can bite quite hard, and also their very large pointy shell is also quite effective when used as a ram. You can actually see that the under the plastron there, they've got these kind of two spurs at the front, which is part of where they get their name from. And the males will actually happily use those to kind of ram into each other during the breeding season. But as I mentioned earlier, there is a threat to these guys, but I also just said that these guys are effectively invulnerable. So what's the threat to an adult sulcata tortoise? Well, living their best cartoon life, the greatest threat to an adult sulcata tortoise is getting stuck on their back and not being able to get back on their feet. Because as you can see, they've got quite a high domed shell, and their neck is only so long. So yeah, in true cartoon fashion, if these guys get stuck on their back, they can't get up, and they essentially just starve or dehydrate to death. And that's the greatest threat these guys have in the wild. So again, as I mentioned earlier with reproductive fitness, it's not about who's the strongest, the fastest, the smartest. It's about who can kind of reproduce the best, and anything that's not an outright detriment generally sticks around. Yeah, that's what I'm talking about. If your greatest problem is getting stuck on your back, you're doing pretty good in life. Okay, last but not least, we have the leatherback sea turtle, Dermochelys coriacea. These guys are really interesting. They are the largest turtle in the world. They are the heaviest non-crocodilian reptile in the world. In terms of size, an adult one of these guys is 1.8 meters long, which is the same height that Ando is. They weigh 500 kilograms. So, you know that sulcata tortoise, how I mentioned earlier, they get to about 100 kilos? These things weigh 5 times as much. They weigh half a ton, which is surprising considering their diet as adults is entirely jellyfish. These guys are actually really important for controlling jellyfish populations. And it's just, yeah, it's fascinating that something this large exists entirely on essentially a jelly diet. They just nom, 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 nom. These guys are actually pretty cool. They're in their own genus, which is Dermochelys, which basically literally means skin turtle or skin shell. That's because, unlike other turtles, they do have a shell. They still have the fused rib cage. However, they don't have the dorsal plates. They don't have the keratin plates on their skin. They just on their shell. They just have skin instead. They do have some ridges of nodules, which you can see, but yeah, overall these guys are smooth if you actually touch them, which I wouldn't recommend because they're hefty boys and they can give you a nip if they want to. But yeah, they're a very interesting species. They're endangered. Most of the issues with them being endangered come from, again, nest predation, damaging the nests while the turtles are developing, and pollution, and also occasionally boat strikes they get run into by speedboats and things like that. But their other big threat is pollution. These are the stereotypical turtle when it comes to the whole mistakes a shopping bag for a jellyfish and accidentally eats it. So that gets stuck in their digestive system. The pollution load in these guys can vary. So one small piece of plastic can kill them, or also they've found examples of these turtles with quite a large amount of plastic in them living quite happily. So, well, as happy as one can be with a gut full of plastic. So it really depends on luck and other factors. These guys also have an issue with a lot of pollutants, to the fact that there's actually been some studies done about how useful they are as an indicator of pollutant in the ocean, because of the fact that these guys accumulate quite a bit of salt from their diet, which means that they also bioaccumulate things like lead, arsenic, and other heavy metals, which means that they can actually be, again, a good indicator for pollution. And also a common thing in sea turtles are what are called lacrimatory ducts, which are essentially tear ducts in the eye, but they're modified to use them to excrete salt when they're on land. So you'll often see turtles sitting on a beach crying. They're not incredibly sad. What's up, Avatar? How you doing? Yeah, so they're not just having a sad time. They're just excreting salt. And so, yeah, they actually will excrete some of the heavy metals that they accumulate through their tear ducts. So it can be useful to kind of sample how things are doing in the ocean. So these guys are actually also one of the deepest diving turtles. They go quite deep. And I had another thing I was going to say, but I've forgotten what it was. Yeah, okay, moving on. Actually, no, I remember what I was going to say. This is about what these guys eat. So they eat jellyfish, right? So this is how they actually eat their food. They have what are called esophageal papillae, aka the throat goat. So this is the best diagram I could find of how this works. Basically, they grab jellyfish, they suck them in, and their stomach fills up with water. So they've now got a stomach full of water and jellyfish. They just want a stomach full of jellyfish. They don't want the water. So they have to vomit out all the water. The papillae, which are the spines, keep it in the throat. So it stops the jellyfish from coming out, but all the water can exit. And it looks like this. Ta-da! Yeah. That's what the inside of a leatherback turtle's mouth and throat looks like. Hence the throat goat. The thrussy. Yes. They look kind of horrific. They're actually not that scary. A lot of people, you see this circulated on the internet being like, this is what turtle teeth looks like. Turtles don't actually have teeth. Turtles don't have teeth at all. We toothless boys. See this grin? It is a lie. Turtles do not have teeth. So these guys are actually just, they're keratinous spines. They've got a little bit of keratin in them to give them a bit of stiffness, so they're actually closer to hair, really. Anyway, let's move on from the papillae to an important question. How do turtles breathe? So I kind of alluded to this a bit earlier with the Cryptodira and the idea of, okay, how do they actually retract their head into the shell and breathe? Well, most mammals and reptiles and other rib-caged organisms breathe by manipulating our rib cage. So when you think of a human has a diaphragm, right? When a human breathes, the diaphragm moves down, the muscle, and that creates a vacuum, a change in volume, which causes the lungs to expand and suck in air. And to breathe out, the diaphragm moves up, which pushes in on the lungs, which pushes air out. This is called tidal breathing. Reptiles do a similar thing with their rib cage, except instead of having a diaphragm on the bottom, they have like muscles on the side of their ribs that they use to pull their ribs open and closed to suck in air. So how do turtles do it if the rib cage is a single solid piece? Like if you can't actually move those ribs. Yeah, fair avatar. Some have more than one diaphragm. But how do you breathe if you can't move your ribs? Well, the answer to that is the girdles. So turtles have two structures called the shoulder girdle and the pelvic girdle. Unfortunately, I couldn't find a great diagram for this, so you'll have to make do. You can see them in the top skeleton there. What they basically do is they move parts of the shoulder and the pelvic girdle outwards. So they move, this one goes forward and this one goes backwards. And this creates the same internal expansion that a human's diaphragm would, in that it creates a change in volume, which causes the lung, which is up here, as you can see in this diagram, to inflate and deflate based on how they move it backwards and forwards. So this is showing it down here. So they move the girdles forward and the girdle back, and it causes the lung to expand, and then they suck in some air. The other thing that turtles have is turtles actually have, unlike mammals who have 4-chambered hearts, turtles have 3-chambered hearts, which it's kind of a bit funky, but basically it means that they get a mixture of, in the third chamber, they get a little bit of a bleed over between oxygenated and non-oxygenated blood. And they have some funky tricks that they can do with some of their circulatory system to close off certain areas of it and close off certain areas of their heart. That basically means that they can isolate the deoxygenated blood and kind of keep the oxygenated blood in circulation for as long as possible. And that's how turtles are able to hold their breath for as long as they can. But we have another trick. And I'm going to embarrass myself by talking about this one. So, let's talk about breathing out the arse, aka cloacal respiration. So, turtles, like any other reptiles, like birds, like monotremes, have what's called a cloaca. So, the cloaca is a single orifice. It's used for reproduction and excretion. We're high speed, low drag. We only got one hole, baby. And so this is again a common hole they use for everything, right? However, many species of turtles have what are called bursae, which are special like air bladders and membranes in their lower intestine. We don't know what these were originally for, but one of the useful tricks they have is that, much like a lung, they have a lot of surface area on them. They've got a lot of folds and other things and a lot of blood vessels in them. So again, much like a fish gill, they're able to exchange oxygen directly from the water into this membrane, which allows them to oxygenate their blood and essentially stay underwater for longer. Now, it's not hugely efficient, so turtles do eventually need to come up to the surface to breathe again. But if you think of it kind of like a fish gill instead of a lung, but it's a lung up your ass and you have to suck water up your ass in order to breathe, yeah, that's basically the gist of it. But it's very useful for a lot of species. Marine turtles will often use it to their advantage because marine turtles very rarely come on land. They often sleep when they're out in the water. They will use it for that because it allows them to basically go down. So marine turtles often sleep in one of two different ways. Either they'll float up at the surface in kind of like a nap. They won't fully go to sleep. They'll just float up the surface, kind of turn off part of their brain and breathe through their nose. Or alternatively, they'll take a breath and they'll go down and they'll have a nap on the bottom of the ocean, on the sea floor, usually hiding under some rocks or something like that. And then they will partake of cloacal respiration in order to kind of keep their oxygen up while they're in low activity state. And things like snapping turtles and stuff will actually use this to hibernate because they actually hibernate in areas that freeze in winter. And so what they'll actually do is they'll stay under the ice when the lake they're in freezes. And they'll either have just a little hole they use to breathe through their nose, or they'll just stay dormant under the water and spend the next, 3 to 5 months breathing through their ass. So I survive winter by breathing through my butt. What's your superpower? So that brings us to the conclusion of our presentation. I figured I'd finish off with the most important thing you need to know, which is that turtles breathe through their butts. That's key learning from today. If you learn nothing else, you have learned that we breathe through our asses. All right. Thank you very much. Thank you, thank you, thank you. So that's been about an hour. I figured that would be close to it. So what I'm going to do is I'm going to close down my PowerPoint and I'm going to find something else to do. So I'm going to send you all back to the loading screen real quick. Just going to scooch that away. I'm going to send you back to the title screen real quick. And did you miss the section on tortoise sex? Not really. I didn't really cover it. It's not particularly interesting nor entertaining. Tortoises, unfortunately, and just turtles in general, because of the whole shell thing, they're not that great on the whole, getting on top of each other thing. It does mean that male tortoises and turtles generally do have prehensile penises, but yeah, the less said about that, the better. So I'm gonna send you all back to the loading screen real quick, and I'll figure out what else I'm doing from here on out.